So it's funny because I was saying to Ryan earlier, I'm like, I'm so glad you're going first because like my brain still hasn't woken up in the last, 2-3 days. But now I see I got somewhat the better end of the deal because it seems like y'all are much more awake. I heard Sydney was an early city. And then, I came here and I'm like, no, engineers all the same globally. It's okay, right? United. Story time. So I am head of MLOps for Feature Farm, and as he kindly mentioned, I was on the ML platform team at MailChimp and Intuit, worked as a data scientist. Kelsey Hightower had this term for it, career mercenary, which a lot of other people call job hopping. So I like Kelsey Hightower's term for it. It just sounds intentional, right? But anyway, so, it seemed like MLOps was starting to kind of, get its feet underneath it. In terms of maturity, in terms of like thinking about what are the practices, the stacks, the tools and technologies that we should think about. And I don't know if any of you guys like had this experience in the last like couple months, but it was funny because I would talk to both like practitioners and leaders and directors, and they started like hitting up my inbox going like, hey, so we had just gotten approved for like an MLOps budget. We have our data engineers, that's great. We have the data. Now we need to start coming up with the platform to centralize like ML workflows. And they had just gotten the budget. They were starting the roadmap. And then LLMs came out. And then more importantly, then it was MLOps, then it was all sorts of like kind of other discussion around it. And so they're asking, they're like, you guys are a feature store. Like, tell us the way. Are you like another vector database? Like what's going on? And so we're like, okay, we got to kind of figure out what's going on here. So that's essentially what the talk is going to be, is not necessarily me going into all the fancy models that are coming out or like the algorithmic advances, but it's like, how do like I as a practitioner or I as a leader try to make sense of like honestly the mess that's going on in terms of Twitter LLMs. So that's honestly just going to be the goals. I'm going to try to present sort of like my view of kind of MLOps, use that to contrast sort of what's going on in the LLM world, and to hopefully, make the doom scrolling a little bit more productive beyond just, churning Twitter off. And I ain't calling it X. Nope, it's Twitter to me. Okay, so just, quick background about who I am. So I have the illustrious experience of working in many, many different roles across many different companies, industries, real estate, anti-privacy, anti-pirating, solar. The anti-pirating thing, I was also just trying to pay rent. I graduated college like 2 years before that. On the one hand, I don't like dinging college students for downloading textbooks. They're just way too expensive, but San Francisco. So that's kind of my background. Okay, so I think it's worthwhile to kind of just talk about the basis of MLOps. Like, what is even the purpose of it? So I think a lot of, ML people, data people, they would argue that the kind of the start or the birth of MLOps was really from essentially a lot of the work that was being, or a lot of the papers that came out of Google with Scully, a few others, with machine learning, the high interest credit card of technical debt, and also the test score paper that came out later on. They're responsible for, one, that image that you just can't get away from. Frankly, anywhere you go, you see that. But they're also responsible for really trying to like coalesce, like how do you measure the efficacy of like production ML? So I think most people would fairly sort of mark that kind of as the beginning. That's not to say that there weren't efforts, right, to productionize ML, but I think this is where people sort of rallied. But we've come a long way, right? Because I think especially a lot of young folks that are coming into like data and ML now, they sort of forget that it actually took a while to get here. There was a number of things that had to happen. Mainly, there's a couple different cycles, right? We had the big data cycle. We also had a lot of work being done with data science libraries that everyone knows and loves, Airflow, you name it. So a lot of things that kind of had to happen. But how do we actually sort of define it? One way you define it is Venn diagrams, like everywhere. it's data, it's DevOps, it's ML, or even saying like, hey, it's decoupling the code and the data and the transformation logic. Or hey, it's just an extension of DevOps, right? Everyone kind of has their own spin on it. But if we kind of just think about what's the core principle of what we're really trying to do with MLOps, is we're trying to make it easier, frankly, for data scientists to build models and to ship it in a way that hopefully doesn't destroy a company, destroy public trust, all that great stuff. That is the core. We can kind of get really super fancy on the definitions and terminologies, but I mean, what's the point, right? I'm also going into a new salty chapter of my life, so this entire thing is served with my native language, which is meme and snarkage. So, but with that being said, like, much like how banana slugs and humans like share significant amounts of DNA, we are in fact not the same. I don't have random college students kissing me in like Santa Cruz, which for all the Aussies who don't know this, there's a university system called University of California. I went to San Diego. Most people probably know UC Berkeley. UC Santa Cruz is another one based in Santa Cruz. And a college tradition they have there is to take on some medicinal herbs, shall we say, and go kiss random banana slugs out in the forest. So we're not the same, humans and banana slugs, right? So there are, volume-wise, there are minute differences, but they are incredibly significant. One of the major ways that I think a lot of folks understand this, but in terms of framing it, when you're developing traditional software, right, in many ways, I don't want to say the data doesn't matter. So don't scare me. I know this is a group of data engineers, right? But you are kind of writing the logic independent of the actual data. You maybe transform the data to fit the business logic, but those things are kind of fairly decoupled. Now with ML-based software, right, it's data drives the model, which drives the code. All these things are very intricately linked. You really can't get rid of one without the other, otherwise you don't actually have ML software, right? And there's other ways that ML-based software really loves to kind of just trip people up. Like the fact that, for example, it's incredibly iterative at every single stage. You could go all the left and right, hi there. You could go all the way from beginning of process where you have your data, you do the feature engineering, you deploy it, and then you can deploy and go wow, this was a garbage model. So now we have to go all the way back to the data. And you can go through this over and over again, and it sucks. And heck, even there's parts of it too that are just so hard to automate. Or if you do automate it, for example, let's say just identify every single timestamp column, and then we'll just do random stuff to it, and then we'll just feature select it, we'll evaluate the model. You could do it, it's costly, it's inefficient. So you still need that kind of business logic and that domain expertise a lot of times to figure out what are the columns you even should be using, right? Now that being said, actually deploying it, I would argue it was frankly a mostly solved problem. You either deploy it as you either do a batch prediction where you cache all the predictions and the inferences, you serve it, you run it on the fly as a live service, dot predict. So for the most part, this was actually a fairly well-solved problem. Nothing fancy. The other part that's also really, really fun, which kind of ties into the whole LLM thing, is the number of tests you have to write. This came out of the test score paper. Yeah, I mean, for everyone who's a software engineer / data engineer, how many of you have trouble getting your data scientists to even write this? Or how many of you are writing this for your data scientists? Oh yeah, yep, feel you, bud. And you know that this is actually what you need to do it well. So yeah, a lot of tests. And even going back to that paper, right, if we think about what are the only things you really have to do for software, maybe some things here, some things there, but all the rest of this, that's hard work. And the question in terms of K&P goal, I would recommend you guys to actually go to the original paper. I'm not going to show up the test scores here. You can see this paper did also help make everyone feel better that oh yeah, the Googlers are not that, I don't say they're not that smart, but they are doing things, they're doing hard things, but they're still people. But there are things that are the same. The spirit of DevOps and MLOps is very, very similar, right? For one thing, you want to make people's lives less hard, ideally. There is something to be said for job security, right? You are trying to kind of minimize/maximize, depending on what metric it is. You are trying to make things either, for example, go faster. You're trying to do more things. And you're trying to make sure you don't get like majorly fined or ruined or something like that when you do it, right? And a lot of times it comes to you're taking different tools and services and supports. You're sort of kind of figuring out what works for your company and team or whatever. And then ideally you have this beautiful developer experience for your data scientists, ML engineers, all that. And it's funny because, even before LLMs came out, MLOps was super important. I think it's more important than ever. There's a number of reasons. Number one, everything is becoming ML, right? So there's a bunch of papers I'm going to link here. Try not to take, there's 145 slides in here, by the way. So don't try to take a picture of everything. I'm literally going to post the slides. Just experience me talking. This is the adoption rates of ML across different countries in terms of deployed, exploring. This comes from IBM. These are all the different use cases. You can see some of them are well understood. Others, for example, are a little bit more interesting. Now, of course, the canary in the coal mine is always banks, right? Wherever they go, you kind of know that that's probably a very serious technology direction. Because I know, for one thing, if my bank is playing fast and loose with my money, I'm so mad. So, it better be good, right? ML in production, it's just different all over the board, right? So ideally, you should be able to answer these questions. But at the same time, what about that developer experience, right? What about that data scientist experience? They go into a new gig, they come out of boot camp. No offense to boot camp grads, I came out of a boot camp, right? So I can say this. And they don't realize that, oh yeah, there's all this other stuff to make it work. You also have companies that there was an attempt to be Google scale and complexity. So that's the maturity model on the left. This was another paper that came out on the right, which I forgot who from Databricks, but he had tweeted this and he was like, see, that's the problem right there, which I thought was a little bit amusing and ironic in many ways. But the part that's really interesting, right, is if we think about what are some of the challenges, a lot of it is data. Deploying and serving, yeah, it could be challenging, right? Monitoring, labeling, yada, yada. So not super fancy stuff. And these are probably pretty common things that people have said. You've heard this. You've heard people say this, right? Another thing is everyone is doing ML differently. That's one of the challenges, right, is that actually there's no quote-unquote right way to do ML, honestly. All these methods work just fine. Whether you do an offline, online, whether you do live versus batch. And we can kind of see this. This is another paper from the AI Infrastructure Alliance. Everyone is on a different journey. Some people will do a mix. For a lot of folks, for example, their next thing they're trying to build out is data. Their next thing they're trying to build out is orchestration pipelines, right? And more importantly, all the data is different. Damn, it's confusing. And on a good day, this is maybe what it would look like if a team has their stuff together. But, it's kind of funny when you have different speakers or different companies kind of align on a similar sort of direction of thought. What happened to do more with less, right? I mean, damn. That's what it was in 2012. Now, everyone loves to hate on the Hadoop ecosystem. And granted, Matrick maybe didn't know all the companies back then. But you think tools get better, and yet we should have more tools, and yet a lot of people, their step actions are being very simple, right? I mean, I think everyone has had this setup, and maybe does have this setup. The funny thing is that we always say more tools are great, but according to the JAM experiment that was done, when they presented more options to people, they were more dissatisfied and felt more FOMO. Now, the correct answer is actually this red and white. Jam is the flavor you should be getting. All their jams are not superior, unless you go to farmer's market, but, so, okay, we have this thing, right? Also, let me just double check. Awesome, fantastic. So, because I love you guys so much, this is the first time I'm doing this talk, which means I also don't know what the timing on it is. I'm just vibing. So, okay, into this atmosphere, we have LLMs. Somehow you have both of these going on Twitter. You have that Woodstock AI party, which I could have gone to, but I'm too cool for that. Also, my entire team was jet lagged, so we were like, no. And they changed the venue 5 times in 3 days. So you have a lot of people shilling all the different ways that you can use ChatGPT to solve your marriage. You have callbacks to Cthulhu. This is great. This was this is a key important way of describing how GPT 3.5 and 4 was trained. So for science. So you have all that going on. You have a lot of people saying like, oh, well, here's the newest like open source LLM that came out. Here's the whatever. This is how you can quantize it. But okay, let's kind of decode the chatter around LLM ops. Me saying that term also is not me advocating that it's a real thing. Just labeling it, I'm just putting it out there. Doesn't mean I actually believe in it, but. So I could have gone this way with the talk, but honestly, there's a lot of people that are gonna be talking about LLMs that are gonna do a much smarter job about it. And I don't understand half these diagrams myself. Because I'm not like an algorithmic person. But what I do care about is the not so sexy part of like how do we actually build stuff and how do we make it work. So let's just start off with kind of MLOps, or kind of sort of my perspective on MLOps, which was still maturing, and then someone had to just kind of like crash the party. And I want to come back to rooting it in like what's the actual like data science workflow? What are the things that data scientists are actually doing? Right? So this is going to be a statement, but I'd argue that actually, everyone talks about how like the tools are crap in ML, and I'm like, no, there are a lot of great tools. A lot of these problems have been solved wonderfully, with the exception of certain key areas, right? But I think a lot of the engines and services are actually good enough that you can do something with. So what's the part that's not actually being solved? You guessed it. It's the thing that's not circled in a box, right? I think that's actually kind of the big challenge, really, in MLOps, and consequently, LLM ops. God, I hope none of you are like live streaming this, because I just need to defend the LLM ops is not a thing. I want a little bit more time to kind of, but okay, so let's go back to kind of what's going on in like the data science ML lifecycle. So this is how I had to kind of first approach building like a data platform for the real estate startup that I did at the beginning of COVID pandemic. My timing has been impeccable throughout my career. Always getting to the hot mess before, it really catches on fire. But, so like I've had to kind of build different parts of a platform or even build a platform from scratch. First time I tried was back when I was, a real data scientist. Tried doing like gigabytes of a data pipeline in pandas. That was before polars came out. It was awful. So what are kind of the 2 dimensions that we can think about the data science workflow or lifecycle, and how do we root it back into what are the actual tools, infrastructure? So first off, the dimensions of the ML lifecycle. People are pretty familiar with it, but if we go left to right, you have the stuff that you do with data. I know that's terribly specific, but stuff you do with data, right? You have to get it in the format that you can apply features to it, all that great stuff. You have to define, for example, if you're doing supervised learning, what's the label versus what's like the features. Then you try out different like ML algorithms. Once you essentially have a ML algorithm that you like, that is hyperparameter tuned, all that great stuff, then you kind of put out into the world, or you figure out what your architecture is. Like maybe you train a model as like a Python library, and then you run it on a table, and then you serve the predictions, right? And then you have to monitor and evaluate it. Now, in terms of the dimension of abstraction, so this is the part that I think where people sometimes make MLOps a little bit harder than it is. I'm not saying that's not hard, but I think sometimes people like to put complexity on their own shoulders, more so than they need to. I think another way we can kind of think about it is like the level of abstraction. So to make this a little bit more clear, so your first two layers, the hardware and the framework, it's stuff, for example, like what's the actual like computing and storage engines that you're actually using? BigQuery, Redis, whatever. And you can think of the framework as like, how are you kind of interfacing with those like compute storage engines, right? So for example, Kubernetes, general purpose, Airflow, all that great stuff. I know they're not the same, but just bear with me on this. These are, in terms of layer 1 and layer 0 in any company, these are more generalized software engineering resources or infrastructure that are not necessarily ML specific. Layer 2 is when we start seeing stuff that is a little bit more like ML and data specific. So from services to workflow to platform, the platform at the highest like layer, going back to what is the purpose of a platform, what's the purpose of MLOps, of DevOps, DataOps, you name it, it's to make people's lives easier. It's to serve as like a unified abstraction that, so for example, someone doesn't feel like, oh, our model's getting passed between different teams. We go from the data team, then we go to the ML experimentation team, then we go to the serving team. When we combine these two dimensions, this is essentially kind of what you see a lot of like MLOps stacks or ML platforms looking like. Once again, layer 0, layer 1, this is your sort of like generalized software engineering compute engine storage layers. They're not going to be specific to ML. Your layer 2 to 4 is where you start seeing, okay, maybe there are certain kind of services or problems that need to be solved at the different stages. But at the very top, once again, that should be the unified abstraction. To make it a little bit more concrete, and of course, we have some of the companies here, so you can just let me know if I'm like way off. But this is kind of where you can think of all these companies sort of fitting in terms of this sort of framework for how I approach like MLOps platforms or ML platforms. And here's the thing, right? Like all models are wrong, some are useful. This isn't gospel because you do see companies that are trying to like expand out up and down, left and right, all that great stuff. I'm not commenting on all of those. And then let's kind of just to further make it a little bit more concrete, right? There are different layers of experiences that you kind of need to think about, or different maturities. So you have your like individual data scientists, right? For a small team. These are all things that they probably care about. Really, what it comes down to is, I need to get stuff done. I don't have a team. I don't have a data team. I don't have an ML team. I just need to like ship. So a lot of times these are going to be like the 4 concerns. I know they were my concern, really, where I was a solo data scientist in a startup, and they're like, yeah, go do AI magic. I'm like, well, first off, it's not AI. Secondly, do I have help? And the company response is, we're a startup. Do you think we have infinite money? No. OK. So, and this is what I love to call the Duke Nukem stack, or kind of the Duke Nukem approach to life. By the way, this is not, once again, this is not gospel. Like, I just have companies up there as an example. But, you know, like if you're, for example, if you're the solo data scientist or whatever, right, there are just maybe certain things you care about. You care about, for example, having access to normal size data or to normal data to do your like ML workloads. You need a place to train your model. You need a way to track experiments. You need to serve it at some point. And you probably need some kind of logging that doesn't have to be ML specific, but just to be like, okay, this thing broke, so yeah. And then maybe you're writing like GitHub Actions or whatever, right? But your perspective as a data scientist, or at least my perspective as a data scientist was, I just need a ship. I don't really care about all this other infrastructure nonsense. Now, once you get to like a data science team of like 5 data scientists, let me just time check. Okay, Awesome. I have the gift of gab, as they like to say, so I could talk for hours. I'm trying to make sure you don't listen to me for hours. So if you're a data science team with 5 data scientists, right? Things get a little bit more complex. For example, you ideally should be collaborating. If you're a single data scientist, you don't kind of have to worry about that, but if you are like on a team, you do have to kind of like share resources. You also want to make sure that if you're starting off as a data scientist, you don't have to like spend 3 months just trying to figure out the documentation, figure out where everything is. And more importantly, at 5 data scientists, you probably have 10 models at least. You know, that's out in the world or being developed. So you need to start having like better monitoring. And I love to call this the serious business stack or the serious business mode of life, where you start caring about things, for example, like, oh, maybe we need more compute. You know, maybe we do need to like containerize like our applications and services. Maybe we do need like ML specific monitoring. And then you start thinking about like the unifying layer. Enterprise org, God, what a hot mess. And I say this lovingly because it's also really fun too. You know, you have just so much stuff going on. Like, for example, a lot of companies say we're not data mesh, and I understand that they're not, but they look like bad data mesh. They have a lot of stuff going on, a lot of different data sources, a lot of different compute frameworks. I know over at Intuit, like at Autodesk, that's a less recent example. Autodesk had about like 70 different products, both cloud and desktop. And then when they did a 13% layoff, however many years ago, they had 50-something products. It was crazy. I was working as a data scientist there for their construction software, and trying to get access to data was hard. And then you do the ML, and it's like, this is also, I can't like ship it. So governance and access control, cross-functional workflows, or the Ollie Oxenfree stack. Short answer is there isn't one I'm going to tell you because everyone's different. But okay, so now let's actually bring in the LLM part, because I did sort of promise that. Like, how do we kind of make sense? So, you know, what's really interesting is that over in the MLOps world, like, we didn't really have a chance to have a modern data stack moment. Maybe the closest thing we came to was the reasonable scale MLOps from Jacobo and a few others. But it's interesting because a lot of times, especially when I go to like certain conferences, I do feel that divide in terms of the conversations that are happening. On the one end, we have the data conversation, right? Then we have the emerging LLM stack conversation. And then we have the MLOps stack conversation. So how do we handle this? Do we just kind of like append all this stuff together? If you're enterprise, then yeah, sure. It's just another like line item. But if you're midsize or you're a startup, is that really the approach that you can take? If there's any kind of, there's a lot of stuff that's being put out there. Honestly, if you had to just focus on 4 diagrams or 4 snapshots of the conversation, these are the 4. So I would highly recommend the State of GPT from Andrew Kripathi. He talks about RLHF and how they kind of came up with, how they actually got to, you know, ChatGPT, InstructGPT, GPT 3.5, 4. Just go straight to the source. Don't worry about all the other Medium articles. The other sort of snapshot of the conversation is RAG, retrieval augmented generation, vector DBs, and this wonderful sort of, you know, proposal by, you know, A16 on what the quote-unquote emerging LLM stack look like. I'm not going into all of them because I already saw the calendar. You have a bunch of wonderful speakers that are actually going to go deeper into those. What I actually want to do instead is I kind of want to build the intuition behind LLMs using the MLOps framing. And I want to shoehorn some analogies. Because that's something that to me was like, I think the big confusing part of the whole conversation that's going is I'm like, this is all really great and good, but how do I make sense of, how do I incorporate these LLM technologies, right, into an existing MLOps platform, an existing ML platform? What's actually the reasoning behind how do I make these decisions? So I still think thinking about the, you know, the dimension of abstraction is really super important. One decision-making point that will sort of impact your stack is, do you develop your own like LM or LM? And you have a couple different options. You can use something just straight off the shelf. You can engage in transfer learning. You can fine tune. And you can go ahead and train LLM from scratch. There are pros and cons to all of these. A lot of people are going straight for the do nothing or for fine tuning. Another decision point is how are you shipping your LLM service? Or is it a system? Is it a service? Is it a pipeline model? Maybe you're just going straight to shipping embeddings. Both these two combined, I think, do have an impact on, for example, the serving pattern. But that's, I think, the level of conversation we should be getting at in terms of LLMs. I don't know about all of you, but I personally have fatigue at this point, looking at the LLM conversation on Twitter. I want to get us to the point where we're saying, look, what is a pragmatic approach to how do we actually build these products? And there's a lot of challenges. Now, what was fun was that these are all the things that people were saying about vanilla ML. All the challenges they're having about vanilla ML. And what's hilarious is that if you actually were to compare them, similar challenges around LLMs. A lot of the concerns around LLMs is actually not super new. People have those same sort of questions and debates about vanilla ML a few years ago and even now. Some key challenges and blockers: security and compliance, performance and cost, governance, data, right? Very similar stuff. Yeah. So there are some contenders. So this was the 2022 ML stack. And this is the beginning of the generative AI app stack. That's MLOps, community stake, Sequoias. But you'll notice that they are actually very similar. They're very similar to a lot of tools that are being used for vanilla ML. There's some similarities with the data stack. So to be honest, going back to the whole, I don't think there's going to be a singular LLMOps or MLOps stack. I hope I've sort of rested my case there. Yeah, ChatGPT will not save your marriage, but it will make some really cool visitor plans to Sydney. So a couple things I want to leave you with as you kind of go into these talks on MLOps and LLMs. First theme, there's 3 Ps for a reason: people, process, product. You can't just go straight to the tool stack. You really have to figure out what question you're trying to answer. What's the problem you're trying to solve, right, in your company, team, or org? I could shill feature form to you, but if you don't but if I don't understand your problem or use case, right, instead I'm just someone who's shilling another tool. And I don't necessarily want that for you, because I've been in all y'all's positions of having to build infrastructure with having, frankly, no sort of support or best practices or anything to lean on. I definitely don't want that. I didn't want that for me, and I don't want that for you. So I think we need to kind of get smart about what questions we're asking about how we build our platforms. Much like how the Earth, only 5% of the Earth is untouched. About 5% of industries will probably remain untouched by ML, but that diagram that I showed you, you notice conveniently there is some data stuff that was missing there. You'll see a lot of this consolidation going on, and I'll sort of talk about why a little bit. The second theme, in terms of strategic LLM and Gen AI adoption. So hopefully the other takeaway is, 1, don't throw away your existing roadmap. 87.7% of organizations polled are seeking to standardize on a single AI/ML platform still. These are the areas of importance from the AI/ML process standpoint. This was published recently. Once again, this is the AI infrastructure paper, one of the AI infrastructure papers. So yeah, a lot of stuff that's still important. I know my positioning at this point is it's not the end of traditional ML. We're going to see it coexisting. Also, LLMs aren't going to save your business. They're not, because I'm wondering if all of you remember, when asymmetry and access to GPT-3 was considered the data moat for most of these companies. And, and then look at that. Some of the existing incumbents went out and built their own stuff. I think this is going to be kind of a little bit of a theme today, is, these lies we tell ourselves about the data-centric and ML-centric divide. The funny part is data is still a challenge, and if anything, LLMs are driving the conversation around good data practices, collecting data, you name it. These are still the challenges that people face. And what was really interesting was, I remember, all of you remember the big data era when we were like, yeah, data is just going to keep on increasing. But the funny part is over in the generative AI researcher space, they're running a little scared, a little bit. And this is actually an opportunity for data practitioners and data experts, because apparently at some point we're going to run out of the stock of high quality academic data for training your own models from scratch, for fine tuning, you name it. Which I found amusing. One of the things that they had sort of talked about was how the stock of low quality data, like web data, is going to run out less sooner than high quality data. Now, of course, the response to this that I'm sure all of you guys are going on, it's like, well, private data, right? Yeah, that is absolutely one answer to this question of how do we solve the we're running out of data for not just traditional machine learning, but more specifically like LLMs. That opportunity for data practitioners and experts. This was one of those things that I thought was a little bit sus, was when we had the prompt engineer role come out. Super sus. Because if you actually look at what the skills are, I tried to find them. I really did. And all this sounds interesting, and then but what you notice actually is one, there's probably only 2 hardcore skill areas that you need to know. The rest of it is apparently things that engineers are regularly accused of not having, which is people and social and communication skills. So I don't know, to me, I have faith in all of us. We can develop these skills. I'm a growth mindset-minded person. So I don't know, this to me just does not justify having a completely different role. That's already kind of divorced from the data ML skill set. And if you look at it, right, yeah, obviously, data engineers, data people, data science. But think about all the other people that are using ML right now. Sales, product, marketing. Why should this be prompt engineering? Why should that be a skill set that, frankly, only one person has? It was kind of like when McKinsey was doing the data translator thing. I'm like, okay, so what we're saying is data fluency should basically be all in one person, as opposed to a skill that everyone should develop. One thing I will say, though, is that a lot of times I've noticed this, people who didn't work as data scientists but who do ML, you still can't ignore the basics. Because I think the thing we do suffer from a little bit is as software engineers, we think, okay, let's just take them all and toss at the data. What I like to call a YOLO deployment. And oh, look at that. The percentages of organizations that incurred losses due to poor governance. It was a lot, and I think it was 20 million, I don't know, it was 200 million or whatever on average, something like that. But I want to leave you with a little bit of a hopeful message, which is that your jobs are not going to be automated out. Software development excellence will always be in vogue. And once again, why? Because stuff is actually messy. Companies are not getting all the rewards that they want to, and yet they want to run immediately to LLMs to kind of save their businesses. What's really funny is that everyone hates Kubernetes, but you know what's amazing is how many of the bleeding edge companies are using it, right? And not just because Kelsey Hightower is charismatic AF. OpenAI, scale it to 7,500 nodes. That was worth a blog post on their site. Some of you are looking for jobs. Well, here's a sampling of Runway ML. Did the text to image, text to video, Gen 1, Gen 2. We have OpenAI. Look at all those skills. They sound pretty, I don't know, vanilla, normal, software engineering, not prompt engineering, right? A lot of CUDA. CUDA is still a problem. So, if anything, those are kind of the themes that hopefully as you guys walk into your sort of panels and breakouts, you really kind of think about. You think about how essentially things in many ways have changed, but they haven't. You're still valuable. The skill sets and experiences you have developed are still important. But more importantly, all this confusion about LLMops, about MLOps, about DataOps, it's going to come together at some point. But I do think part of it is stepping back away from the weeds and coming back to what is the problem that you are trying to solve for your team, your organization, even for you as an individual. And start from there when you're making your tooling infrastructure choices. Because if you do that, things get a lot more clear. You're not going to be shystered by a bunch of random influencers talking about 35 ways that ChatGPT is going to steal your jobs. So I hope that instead of being kind of scared about all this LLM stuff, even instead of arguing titles and distinctions, we focus back to value creation, and we focus specifically on value creation for your end users, for you, for your data scientists. And that is it. So catch me later today at the panel.